Kia ora tātou. In this video we'll look at addition reactions and we'll break it into two categories. The first category is where we can only get one product, and the second category is where we will look at addition reactions where you can get two possible products. So the first types of addition reactions, and addition reactions are always going to start with an alkene. The reason they'll start with an alkene is that we need to add to the molecule without taking anything away or without substituting anything. Otherwise that would be an elimination or a substitution reaction. So the only way that we can add to a molecule is if there's a double bond, so that the double bond can break, and then we can end up adding more atoms or more molecules onto each carbon on either side of the double bond. So the two addition reactions that can occur, which will form only one product, is if we add a halogen to the alkene. So in this case, if we had bromine or chlorine, a bromine atom would attach to each of these carbons on the alkene molecule. So we would end up with, why not draw it in blue, Br if we were using bromine, and then the rest of the hydrogens would stay. So we've got H all over there like that. This is a common one that comes up in an exam because bromine, it's normally using bromine, is an orange or brown colour, and the product that gets produced is a colourless liquid. So what we would get is, if it's a long enough chain, normally you would use hexene as the starting product, which would be long enough to be a liquid. So you'd get a colourless liquid. So how would you know that the reaction has taken place? Well, what you would observe the orange colour of the bromine turning to colourless. And this reaction happens quickly and without the need for a catalyst. The other reaction that would only have one product is if we have hydrogen and we'd need a platinum catalyst or a nickel catalyst for this reaction. And that we just add the hydrogen onto each side of the carbon, onto each side of the double bond, so we end up with an alkane. So it'll just be a single bond because the double bond breaks and those extra hydrogens get added in. So in this case we would just go from ethene to ethane. In this case we'd go from ethene to 1,2-dibromoethane. So those are the two reactions here. One, this is the one that comes up the most often, and two, using hydrogen and a platinum catalyst. The next type of reactions can give two different products. And so that can only happen though if we have got an asymmetric alkene. So that means that we've got an alkene that has a double bond, and each carbon on either side of the double bond has a different number of hydrogens attached to it. So the options that we can have here is that we can either add, I'll move this across a little bit again, we can either add water, we can either add H2O with a acid catalyst, so it's normally dilute sulfuric acid, and we'll look at this one before we look at the next one, which would be adding a hydrogen halide. So if we add dilute sulfuric acid to this, then what happens is that the water molecule will add on to this compound here. So if I draw water out again, just using different colours, so we've got water, which is H2O, then H. So the hydrogen, one of the hydrogens will attach onto one carbon, and then the OH group will attach onto the other carbon. So you can see how this could be two products from this, is that the OH group could actually go onto this carbon and the hydrogen could go onto this carbon. So let's have a look at what those two different products could be. So we would have, in the first one, if we have the hydrogen attached to the first carbon, then we would end up with, this would have 3 hydrogens attached to it now, and the middle carbon will have an OH group attached to it. OH. Or it could go the other way where we have the hydroxyl group attaching to the first carbon. So it'll be like that, and then the other hydrogen will attach to here, so it'll go from having just one hydrogen to now having 2 hydrogens. So that's all done there. So we can see that these are structural isomers of each other. This one would be propan-1-ol, and this one here would be propan-2-ol. So what happens with these type of addition reactions where we get two possible products is that the rich get richer. So this is called Markovnikov's rule. Markovnikov. M-A-R-K-O-V. Markovnikov. And so that means that the rich get richer. So the carbon that already has the most hydrogens is going to gain another hydrogen. So when we're talking about the rich get richer, the currency is hydrogens. So this one has got 2 hydrogen dollars, and this one here has got 1 hydrogen dollar. So the major product is going to be that the rich one, which is this carbon here, is going to get richer. So when we go in this direction up here, this carbon goes from 2 hydrogens to 3 hydrogens. So this is the major product. What is meant by that is that this just gets produced most of the time. Maybe 75% of the time, we're going to get propan-2-ol as a product. And then in this one, this goes from having 2 hydrogens to still only having 2 hydrogens. In this case, the poor get richer, and that happens as the minor product. So this is the major product up at the top, and the bottom is going to be the minor product. So the other type of addition reaction that can occur like this is if we have a hydrogen halide bonding to it. So again, we could have, let's say we've got HBr. So there's going to be 2 possible products because the hydrogen can go either to that carbon or the other carbon, but we use the same rule. It's still the rich get richer. So this one has got 2 hydrogens, and so as a major product, that is going to gain another hydrogen. So if we put the hydrogen onto that carbon, so that carbon's now got 3 hydrogens, the bromine onto that one, that will be the major product. This carbon here is just that carbon there, just for reference. So this is the major product, and then down the bottom will be the poor one, this one here getting poorer, or getting richer, sorry. So the poor getting richer is the minor product. So it would be C, C, C. That would mean that the bromine attaches to the end product there. We've got the hydrogens there. So it's normally HBr that you see as this addition reaction, but it could be HCl as well. So those are all of the addition reactions that you need to know. So remember that an addition reaction always starts with an alkene. There are 2 addition reactions that only have 1 product. So that is if you're adding hydrogen or bromine and chlorine. And there are 2 addition reactions that have 2 possible products. So that's if you add a hydrogen halide or water with a dilute acid. So dilute sulfuric acid. Thanks for watching. I hope that helps with Markovnikov's rule. It's a very common exam question. So do some exam practice. As always with this, check your answers with the exam answers, and I'll see you for the next video.